SAROS Desalination project. We know that access to water will be and will continue to be a major issue in the coming years. And here they are to tell us how they aim to bring clean, accessible water to the masses. So welcome to Justin Sonnett for SAROS.
All right, thank you, David. So water scarcity needs no introduction. The fact that people around the world are dying because they lack access to clean water is unacceptable. With water scarcity all over the news lately, I'm sure most of us are aware that we have a big problem. And when we picture water scarcity, we probably imagine something that looks like this, right? What if I were to tell you that many places that struggle with this, their water scarcity issue looks like this? This doesn't look too bad, right? So this is a picture of the Caribbean islands map, and these dark red and orange regions, they show areas that are struggling with water problems. And it's hard to imagine that these places have issues when you're surrounded by water. But all of this water, to them, it's seawater, so it's useless. It may as well be sand. In parts of Trinidad, for example, many of the locals there are forced to rely on an unreliable, dirty supply of water from a barge. Many locals have to beg or even steal just to survive the dry season. Wells don't work here because the groundwater is salty. Desalination is pretty much the only alternative. So desalination plants, they come with a lot of drawbacks. So first of all, they're very expensive. They require massive amounts of energy to perform, and desalination is harmful to the environment. So I'm here to tell you about a solution that addresses all of these issues. And this is what it looks like. So the water in this bottle is desalinated and purified using no electricity, no fossil fuels, and with virtually zero environmental impact. And to speed it up, we can do that at a cost less than what many people are paying now. So it sounds too good to be true. What's the secret? So SAROS is powered by nothing more than the motion of ocean waves. Our patented floating unit gets anchored up offshore. We're passing waves from a large, heavy pendulum. This pendulum drives pumps, which draws in seawater, pressurizes it, and puts it through reverse osmosis. The desalinated seawater is then pumped back to shore and collected. So this has a number of advantages. So this is what we envision a typical SAROS installation looking like. See, these white dots are individual SAROS units. They're decentralized, and they're mobile and they're modular, so they can be moved around or grouped together to meet demand at that time. Low cost, so since we're cutting out that huge operational energy cost of typical desalination, we can produce water for less than what we pay now. Also, SAROS expands the water supply. So we're not just reusing existing surface or groundwater, we're actually bringing new water into the system for reuse. As I said, it's environmentally friendly, so there's no electricity, no fossil fuels, and it emits a much lower concentration of brine, so you get happy fish. This is our alpha prototype. The mobile unit has a low upfront cost, so it gives access to a lot of places that traditionally or previously would not have access to desalination due to the expense. So we're initially going to start out by targeting developed island communities, likely in the Caribbean. Then once we get traction in this market, we'll move into underdeveloped regions through collaborations with NGOs. Military and disaster relief applications are also strong possibilities. This is our team, so we have a 3-person team. We've been working on this issue for about 2 years now, and our skill set spans from design and engineering all the way through to marketing, research, and development. And we also have an awesome advisory network. So we have a great advisory network that has international ties in the investment, startup, and energy sectors. And as I said, we have a functional alpha prototype, so the next phase is we're starting development of a beta prototype that we hope to have to our initial users in the Caribbean within the next 12 to 18 months for a pilot study. And really this is about more than just water. By giving these communities control of life's most essential resource, you're empowering them towards a sustainable future. So we hope that this begging and stealing that goes on now to get the water they need to live becomes a thing of the past. So thank you. If you have a chance, I'd like to invite you to come by our booth and learn more about the technology. I'll be happy to take any questions.
How many hours of functioning do you have on your first samples, the one that we've seen, and what is the capacity in production of such a unit that we saw behind the SUV?
Sure. So we have about 6 tests on this prototype. Each one is about a day long. And the prototype that we have now makes about 180 gallons a day in basically heavy wind chop conditions. So does that answer your question? Also, I'd like to say that the output is also scalable exponentially. So if we make a unit with a pendulum twice as big, you can produce about 800 gallons a day, so 4 times as much water.
Another question, just collecting on this, actually, how do you bring the water then back on shore? And this is particularly asking in the context of scalability. So when you actually do increase the scale of these, how do you make sure that you get this on ground? And then I understand that the floating platforms are anchored. I mean, are you also looking at mooring systems, or how do you envisage them the larger scale of this?
Sure. So water transportation, great question. These units don't go far offshore, so we just run a small flexible pipeline back to the beach where it can be collected on the cistern. We can actually use the differential pressure from the reverse osmosis process to drive that flow, so we won't need any auxiliary pumping system. And then the second question was about scale. Sorry, I forgot.
Yeah, so if you have several, so that's on the unit level, but if you have many more, then how do you connect those? So
Right, so
each one with a single pipe, and at the wave power will actually allow the pumping to happen.
correct. Yes, you would link them together in a network and then probably run one pipe back to the beach. And you asked about mooring, I think is what it was. Right now we're using the typical standard boat anchoring system that self-orients into the waves. It's likely that system would work for most places that have sandy bottoms, but it really depends on where you're putting it and what the bottom looks like.
Can you tell us something about cost metrics comparing this method of desalination to either traditional methods or not so traditional ones like solar?
Certainly. I had a slide up there that actually had a graph of it, but we're estimating we can produce water for about a penny and a half a gallon. So there are a lot of places like island resorts, parts of Trinidad where people are running their own personal desal units, but they're paying 3, 6, 8 cents a gallon in some cases. It's really volatile to economies of scale as well as need and location. So it's pretty good because we don't have that huge energy expense that normally is what drives the high price of desalination.
Thank you.
All right.
Thank you, Justin. Thank you.